welcome back to the second semester. This is our first lab day of the second semester. And so because we don't have you guys in school, we wanted to do a little demonstration for you guys instead. We did this a little bit at the beginning of the year as kind of just a fun demonstration, but now we want to describe some of the science behind it. What do we have here, Mr. Pilcher?
Well, over here on your left is a hydrogen balloon, and on your right is a helium balloon. And we're going to sort of see how these two elements react differently during today's lab demo.
Perfect. Dr. Yates, you want to explain some differences between hydrogen and helium for us?
Well, if you look at your periodic table, like we have behind us on the screen, we kind of have hydrogen and helium. They're in the first row. They're first, what's our first row called? Our first period.
Nice.
They're in our first period, and hydrogen's on the left side, helium's on the right. But notice there's only two elements in that first period. Only two elements in the first period. And that's what makes this significant as we look at the other elements in the periodic table and whether they were an alkali metal or an inert gas on the right-hand side. Right? There's only two elements. We have a left and a right. And that's what we're showing here. Just in that first row, there's only two of them, not 8 or 18 as we get farther down on the periodic table.
Perfect.
And we're going to make a difference, show you the difference. What does it mean to be on the left side of the table versus the right side of the table?
So a lot of this we're going to do this demonstration earlier, and we'll be able to reference this back more as we talk about the different trends on Monday's lecture and as we talk about the electron configuration on Tuesday's lecture. But so if we show you this now, we can then reference back to this. So you guys had said, now we know why the trends are and why these are located where they are.
Yep.
Another reason why, for you history buffs, we also like to throw in a little bit of history here. So you will see both of our balloons are floating. So sometimes people wonder, why can't I use hydrogen in my birthday balloons and why should I be using helium? One example would be the Hindenburg.
Oh, yeah.
Behind us, who was a very interesting historical moment. They filled up a giant balloon, and you can see compared to the Goodyear blimp, how much bigger the Hindenburg was. It was a German vessel, aeronautical vessel, if you will. And they filled it up with hydrogen instead of helium. And then it had a very bad day one day when it built up too much static electricity on the outside of it, and it caught on fire. One of the interesting things is that they did have a smoking lounge inside there, which when you see what we do with the balloons is going to be interesting here. And it flew all over the world. And then had a very tragic day on May 6th in 1937, where 36 people died, and it burned, the whole entire thing burnt in 34 seconds. And once you see how we're doing the demonstration, you would understand why it was probably not the best idea to use hydrogen in the Hindenburg, and maybe they should have used helium.
Which is an inert gas.
An inert gas.
Oh,
fantastic.
Dropping new terms.
So the first balloon we're going to work with today is going to be our helium balloon. Helium, if you remember on your periodic table, is over here on the right-hand side, top of the right-hand side. And what do we call that most right column? We call that the inert. They're inert chemicals. They're the noble gases. Inert meaning what? Inert meaning they do not react.
No reaction.
So
no
if you put a flame to an inert gas, it shouldn't really do a whole lot.
Other than pop
the balloon.
So these are helium, and this is your inert gas. Ready?
I'm going to pop mine first.
No.
Oh!
All right.
Not too much there with the inert helium gas.
So now, if you look on the top left-hand corner of your periodic table where hydrogen is, it's hanging out in the same group as the alkali metals, which are known for being very reactive. So unlike the inert, non-reactive helium noble gas balloon that didn't really do a whole lot, these should be a little more exciting. So we're going to go ahead and turn off the lights here in a moment to really get you guys that great shot of what a hydrogen balloon will do. So I'm going to go ahead and turn my lights off the magic snapper. Now we're going to go ahead and light. Oh, goodness. I always get so nervous. I don't like it. I just feel nervous. Okay, you ready? 1, 2, 3. Oh! I don't like this. Oh! I hit it like 3 times. Oh, it makes me so nervous. I don't like that.
Some of us don't know chemistry, Mr. Pilcher.
What?
All right, turn that.
I know the chemistry. It's just eerie.
right. So what we hope you got out of this demonstration is that there is a
Things still on fire.
We're okay. Is that there are major differences between reactive and inert elements. Mr. Pilcher's going to take a moment between inert and reactive elements. And so we're going to be able to reference this again as we do our lectures next week. So thank you guys very much. Good luck on your quiz tomorrow. Let us know if you have any questions.